Hello, Chris Odom here once again. For this video, I'd like to talk about smart contracts. So let's just get right to it. Well, I just finished recording the market exchange video, and we can see our balances are now all updated from the market trades that occurred. And now I'd like to move on to smart contracts. Now, all of the financial instruments that are used in Stash are cryptographically secure, and they're all very similar instruments, and they're all based on the same basic core transaction processing system. If I just look at a check here really quick, you see what the check looks like. It's got an amount. That's in cents. That'd be that many dollars there. Various IDs and so on, the memo, the signature. So now if we look at a smart contract, this doesn't really matter what I put here. All right, so with smart contracts, you have a sort of irrevocable section where you can force certain things. Like you can say that NIM IDs have to be explicitly specified on the template, so that when you create the contract, you have to put the NIM ID on there. Or same for asset IDs. So it's just an option. You can see here, I turned them both on. I don't know why. I think I could do it without doing that, but it's too late now. So now notice, first of all, that here's the contract, the smart contract itself that we're working on. It's mostly blank, not much to it. It's got a signature. And now let's go and add some parties to the contract. By the way, I should mention for the record that Stash Toolkit is a low-level tool and does not represent our concept of the importance of user interface design for crypto software, which we're really pushing in our Android app right now, as you can see. So this is a low-level tool, but it does allow me to kick the tires on the protocol and show that it's working. So let's see, I'm going to use Bob, I guess, for marketer 1. Get his NIM ID. First marketer. Okay, so there's the first party. And then I'm going to grab Alice's ID as well and add a party, and we'll call that the second marketer. So that's Alice's NIM ID. So now we have these two parties that we've added to the contract, the first marketer and the second marketer. Now, a smart contract is very similar to all the other instruments. The main differentiator is that it's a programmable instrument. You can create custom scripts that execute at certain trigger points inside the smart contract. So you could use it for all kinds of cases, like a escrow or a money splitter. Let's say that two people are getting paid and neither one of them wants the other one to receive the money first. They both want to receive the money at the same time. That's kind of the idea that I was building with this smart contract here. I'm going to make another one that would be like the customer. So I'm going to make another user, actually, another NIM, just for testing. Of course, I have all these NIMs in the same wallet here. So I'm going to add Charlie. And I'm also going to open an account for Charlie, a dollar account. So we'll just add Charlie's dollars. And we'll put some money in it as well. So I'm going to make a payment to Charlie. We'll pay him some dollars out of Alice's account. And we'll give him 1,000, or I don't know, 20,000. Just so I can have a third party for the smart contract for the testing. So Charlie's got some money. You can see here from Alice. And that way we can have 3 parties on our smart contract. So I'll add a customer party. Say. Put Charlie's NIM ID. So now we have a party customer, party first marketer, and party second marketer. And like I said, for this example, I want to make a splitter. So it takes some money from the customer, and then if that's successful, then it gives some of it to the first marketer and some of it to the second marketer. And that way the 2 marketers don't have to trust each other, or each one of them doesn't have to trust the other to receive the money first and then split him his share. And by the way, if we go and look at the smart contract, you can see the parties are starting to show up here in smart contract. There's the party first marketer and party second marketer right there. So we're actively editing this smart contract. And notice that each party has agents who act on the behalf of that party. Now right now a party is a NIM and an agent is the same NIM acting on behalf of himself. But someday a party could be, say, a digital corporation, and the agents could be specific NIMs that are authorized to act on behalf of that party. And we can also add accounts so that each party may have an account listed on the contract. So let's go ahead and do that. So I'm going to add the customer source account, say, which will be dollars. And of course, each marketer will also have a dollar account. This will be first. First recipient dollar account, and I have a second recipient. Dollar account. So now each one of these has a dollar account. Now notice it doesn't actually show the account ID because that hasn't been selected yet. That would happen at the time that the smart contract is activated. Each party would select his dollar account at that time. So now let's go ahead and look at bylaws. And there's every smart contract, of course this has none right now. So every smart contract has a main bylaws, which is the default first one. You can see here it says script language, Chai. So the truth is it's very easy to integrate scripting languages into open transactions. And as a result, we could have multiple bylaws here, and each one might use a different scripting language for its set of clauses. So that's something that's possible in the future, relatively easy to add. But Chai script is the scripting language that we have in there right now. And you notice that this bylaw has variables on it. It also has clauses, hooks, and callbacks. So what are these? Well, a variable is basically just a variable that's available in any of the scripts. So I might make a variable that is customer amount, which I'll make a string, say, and I'll give it a value of 1,000. And I'm going to go ahead and add a couple more variables. We'll have the first amount, and we'll set that to 250. And we'll add a second amount. We'll set that to 750. So the two amounts add up to 1,000. The idea being that we can take 1,000 from the customer's account and then pay 250 to the first marketer and pay 750 to the second marketer. Just for the heck of it, I'm going to go ahead and add a Boolean variable we'll call success. I'll call it overall success. How about that? Make that Boolean then we'll set it to false to start. So there's that overall success. So now I want to have a clause, and I want this clause to trigger when the smart contract is activated. So I'm going to make a hook. We'll do the onActivate hook. Now to keep it simple, we're just going to have this contract run once and then deactivate and finish. But you could have a similar contract using onProcess hook. You could have a similar contract that triggers over and over again on a regular basis. But in this case, I'm just going to have this one action occur on activation. So the cron activate hook triggers the onActivate clause, which it just generated. Here it is. And let's move this up here. Not too difficult to generate the function, which is empty, the little empty script function. Well, let's say we want to have some behavior occur when the script activates. So maybe I want to say success taking funds equals, this will be a Boolean, true or false, success taking the funds. So I'm going to stash funds from the account customer source, and we'll just call the stash blah. It's a named stash. It's a place where you can put money that has a name on it. So I use the name blah for this test. You're going to take some money out of this account and put it into this stash, and we're going to use the amount, I believe I called it customer amount. Now notice, by the way, that an actual account ID never appears inside the script. The script doesn't ever have an account ID, and that means you could never have some bug or security hole where a different account ID is substituted. Anytime it refers to an account, it refers to it purely by the name. And the name of the account has to be, if we look at the parties, it has to be an account that is named on the contract. And when the contract is activated, then the party will choose his account ID, and he has to be a signer to the contract and the owner of the account. So it's just a security mechanism there. So next, what I want to do is have some logic based on whether this was a successful action. You know, maybe this failed because the account was empty. So I'm going to say if not success taking funds, then we'll do this behavior. Else we'll do this behavior instead. So what do we do if there's not success? Well, just to keep it simple, maybe we'll just deactivate the contract. Now what if we do have success taking the funds? We will unstash it. Remember, we stashed the funds inside the contract itself. So the contract is now holding the money, the $1,000 or 1,000 pennies, whatever amount I put. So now we're going to unstash funds. And we're going to do this for both of the marketers. So we'll unstash to account first recipient. We'll unstash it from the same location where the funds are. And we're going to unstash the first amount. And we're going to do this also for the second recipient and the second amount. So here we take 1,000 out of the customer source account and place it inside the contract under this name. And then if that fails, we deactivate. Else, if it's successful, now we unstash it from that same location into the first recipient's account in the first amount and the second recipient's account in the second amount. And in that case, we also want to deactivate the contract. I think it's done. We could have a contract, like I said before, that just runs over and over again based on some rules. And also, I had a variable called overall success You can see here, overall success, a Boolean that I set to false. So I'm going to, in this case here, I'm going to set it to true, like that. And that way, whenever you get the final receipt, this variable will have that value true set on it in the receipt or not, and the client software can process it accordingly. I wouldn't be surprised if there's customized web pages designed for various different smart contracts. And I have to say, a smart contract is not the sort of thing that you just run willy-nilly. It's the sort of thing that needs to be tested in simulation, and just really treat it as a serious tool that it is before you're putting real money into it. And now take a look. If we look at the smart contract now, we can see we've got the agents on here. We've got the parties that we had before. We've also got the variables. Here's the main bylaws, the language. We've got a customer amount variable. We've got the first amount variable, the overall success Boolean variable starting out at false. We've got the onActivate clause. This is the actual base64 encoded script code of that script that we wrote for the onActivate clause, and also the hook that triggers that clause when the contract activates, and the signature at the bottom. So now I should be able to activate this contract. I have all 3 NIMs in my local wallet that I could test it with. So I'll see all the sent and received messages and notices and everything as it's running. So let's go ahead and run it. So this will be the splitter smart contract. And let's run it. Now, I'm going to start off as Charlie, and he'll be the customer. So he's going to sign as the customer party. And of course it's telling me that this customer has an account, and we need to pick his account on the contract. Put Charlie's dollar account. And now we're going to send it on to the next party. And so the next party, I guess, will be Alice. Got a little bug here. There you go. So success sending the agreement on to the next party. So now I should have it in my sent box, and Alice at some point will have it in her receive box. You see here, pending outgoing smart contract. And we look here in the receive box, we have a pending incoming smart contract. And there's the instrument itself for the Curious, the same instrument that we created. I'm going to go ahead and sign this smart contract. Okay, so here I can sign this smart contract. I'm going to sign it as Alice. She'll be the first marketer. So now normally the party may have several different accounts here, but in this case there's just one. So we'll use Alice's dollars. Interesting. Now if you recall, we had to specify the NIM IDs on the contract, and so it looks like the first one was Bob, not Alice, and it's not allowing Alice to sign this contract. I think it'll only allow Bob to do it, but that's fine because lucky for me, Bob happens to be in this wallet, so he has the power to do that. So I'm going to have Bob be the signer as the first marketer. Choose Bob's dollar account. And then we're going to send it on to the next signer, who will be Alice. Success sending the agreement on to Alice. And presumably she'll be signing on to the agreement as the second marketer. So Charlie sent it on to Bob, who sent it on to Alice. So Alice now has it from Bob. So now Alice is going to sign the contract. And she's going to sign as a second marketer, which is notice the only party left. The other two parties are not available on the list because they've already signed the contract and passed it on. So now it notices that that party has an account. Could have multiple accounts, but it has this one account, the second recipient account that we created. And so now that we're signing as Alice, it wants Alice to pick an account to be that account, which is Alice's dollars in this case. Now let's go ahead on over to our active agreements page. We can see the outgoing smart contract, and we want to see its state update as we start getting the activation notices and hopefully payment receipts, assuming I didn't have a bug in the contract. Now I can see we got some receipts. We can see that the activation notice occurred. We can see that we have multiple activation notices because we have multiple NIMs in this wallet that are all parties to the same contract. And there's the payment. It's 1,000 pennies. So that payment was made. So the funds were stashed, in other words. But what I don't see is where the funds were unstashed. I don't see the payment receipts coming in on the receive side. And the reason, as you can see, possibly, the reason is because I actually have a misspelled variable on the smart contract. The variable is one letter off from the variable as we're using it in the code. So I had to actually go and rename the variable on the smart contract, and I'm going to have to run it again to finish this demo. We can see now there's the second smart contract that I ran to finish the demo. It's got a status of incoming. Here's the pending incoming smart contract from Charlie, waiting for Bob to sign it as the first marketer. So I'll go ahead and have Bob do that. Sign this smart contract as Bob, first marketer. I've got to choose the first recipient account for that marketer, Bob's dollars, and send it on to Alice. So now we can see Alice has received it from Bob. We're going to have her sign the contract. Alice as the second marketer. Second recipient account, which will be Alice's dollars. And should just kill this one. Just kill it. But anyway. And now we can see the smart contract has completed. It's no longer active. We received the 3 activation notices for the 3 different NIMs who are parties to the contract. All 3 of them are in the same wallet. And we can also see the 3 final receipts. And also, there was that payment, the $10 payment. And here we can see the $250 and $750 that were paid to the first and second marketers. So I would say that was a successful demo of that smart contract.